Hey, everybody. And hey, Z, good to see you. Yeah, so this is the first Plutus PBL live coding session of 2023. My name is James, and we get together every Wednesday and Thursday to jump into not just Plutus. We call it Plutus PBL, but really it's about seeing where Plutus fits into the Cardano development stack. And we are recording and live streaming this meeting just so anybody can catch up with it anytime. So if you can't stick around live for the whole meeting, you'll be able to catch up with it later. And for anybody who bumps into this video on Twitter or YouTube, you can join us. The details are on the calendar at gimballabs.com and also in the Gimbal Labs Discord, where there's lots of people who can dive into any development questions you have. This year on Wednesdays, we're going to use this time every Wednesday at 14:30 UTC to look at development work that somebody's doing. If you've been to our weekly playground sessions, it's going to be similar to that, but with a little bit more of a technical focus. I'm going to take the lead today, sharing a couple of transactions on the current iteration of GPTE, which we've covered in some previous sessions, and we've covered in the Plutus PBL course. But I'm really hoping that I can just serve as a model for other folks who, if you've been building something, whether it's related to the GPTE, if you're working on extending that project, or anything else you might be working on. The idea is for this to be a venue where people can come, share out, and build expertise together. So the agenda for today, I'd like to quickly review some goals and then jump into 3 transactions on GPTE. One, I want to look at a commitment transaction and just show the role that inline treasury datum plays in that transaction. Then a distribution transaction to think a little bit about how the prototype of CIP68 compliant metadatum works in a distribution transaction. And then if we have time, we'll take a quick look at how contribution tokens are minted. Now, all of these transactions are Plutus V2 contract interactions. And as you'll see, both the commitment transaction and the distribution transaction are interacting with multiple smart contracts. So that's why I'm hoping this is a really helpful example for us to look at together. Just to go over our goals for a moment, these are why we built this thing. It's live here at gpte.gimballabs.io. Okay, and anybody can explore this. We'll come back to this in a moment and bounce around a little bit as we look at what's going on. And what we're trying to accomplish is, at a very high level, we know that the Cardano development ecosystem needs greater development capacity. So we're trying to contribute directly to that, building up with each other our own skills. GPTE is a focal point of the Plutus PBL course. It gives us a hands-on project to introduce in the course. If you've been taking the course, you've already played around with it a bit in an earlier iteration. We want to explore how to create a production-ready headless dApp. This is a big topic that we're not going to really cover today. But if you've taken the course, you're familiar with this one. We're looking at reputation systems. We'll think a little bit more about this in a moment when we look at the contribution token data. And like I mentioned, every Thursday, we're going to meet at the same time as this meeting to look at the list of projects together. So this list of projects that's live and posted, first of all, it's ugly, right? So that's why the first project right here is to start making this page right here look better by creating other styles for these project cards. But the work of even deciding what projects are listed on this page is governance work. And it's a fine-tuned, small-scale governance work. And this project gives us a chance to think about governance from this. I almost think of it as like the local version of governance, right? Compared to maybe like Project Catalyst, which is more like a federal government or even the United Nations. The work we're doing here is the stuff that might happen in City Hall, right? What are the fine-tuned things? When is somebody going to come collect my trash, right? What are these small things that we have to do? This project is designed to give us a venue for doing that fine-tuned small-scale work. And as other communities take this project on and start to fork it, create their own instances, that's going to create really interesting context for us to engage across communities. I don't know if we're going to cover all of these today, but just keep these in mind. And you've got this link right here so you can revisit these goals anytime. Any clarifying questions before we jump into the real part of today's presentation, looking at some transactions? All right, so we're going to start with commitments. I think, yeah, I'm on testnet here. So if I connect a wallet and I jump into any of these projects, I can see whether or not I have contributor tokens in my connected wallet. And first and foremost, you can see right here that this connected wallet doesn't have any. So I'm actually not going to be able to commit from this wallet, but I have another one. See if this one works. Where if I reset the page, let's see if I have any here. Oh, you know what? I think maybe I committed all of these. Let's see. Oh, no, sorry. I'm on mainnet. Sorry, everybody. I'm on the mainnet instance right now. That's why I can't see my tokens. Okay. Let's, yes, this is live on mainnet, but if I'm connecting via testnet, of course, that's not going to work. But there is. There's a pre-prod version here. Okay, that's going to work better. Sorry about that. Let's connect to this wallet instead. And let's go look at a project. There we go. There's some contributor tokens in a wallet. And so since I have these contribution tokens, I will be able to commit. And so I could tap the button. NAMI pops up. I can see that there's two contracts we're interacting with right here. This is the project treasury that has a bunch of ADA and test gimbals in it. This is the escrow contract that's going to receive my contributor token, the gimbals associated with this project, and the Lovelace or ADA associated with this project. There's also some metadata, which in the long run may not be necessary to include all of this. But what I want you to see right here, without jumping straight to that one, what I want you to see first is a failed transaction. And this one right here is going to fail. So let me try to commit here. Sign it. And I get the message, okay, wallet could not send the TX. And I just want to show you this. We're still in this stage where that's not always going to be a helpful message, right? And even if I check the development console, I don't actually get any helpful messages yet right here, okay? I'm doing this with NAMI. Eternal, in my experience, makes it a little bit easier to get a good error message, and it shows you more details when you try to submit a smart contract transaction. You're going to be able to look at more of the data and metadata. But for now, I just want to show you, okay, this one fails, and I want to show you why it fails. So let's go back. And actually, it really doesn't matter which one of these I attempt to commit to, because, and you can see we're logging all sorts of stuff we don't need, and because we're in just an early mode, right? I'm tending towards including more information than is necessary. But I want to go take a look at this contract address. This is our treasury address. And it has, I'm going to cancel this because I know it was going to fail. This treasury address has some UTXOs at it. And if I go to a recent transaction and I look at the UTXO that was output to this address last time we interacted with it, I can inspect this datum on Cardano scan. And also if you have Cardano CLI running and you query UTXOs, you'll be able to see that there is inline datum at this address. And if you save that output to an out file, you can save it as JSON, and you'll be able to see this datum directly. So what is this datum right here? This is the inline datum at the treasury address. And each of these byte strings right here represents the hash of some bounty that's listed in the system. And I'm still using the word bounty, I can't sometimes. So we have this. Let me go back here again, okay? And I showed you that when I tried to commit to this project right here, the transaction failed. The reason is this project hash, BA5DB, is not in the list of approved projects at the treasury contract, okay? So a couple things I want to consider together right here about this architecture. First of all, where does this hash come from? Two, how can it be changed, right? And how do I, what purpose does this serve? Well, where this comes from is we're just simply using the Blake 2B library in JavaScript. It's just imported as a package, and I'll jump into the code in just a second. And this byte string right here is just calculated from the content of the project description itself and the amount of awards associated with it. So if this number changes, or if this number changes, or if any of this descriptive content right here changes, this hash will change. When it changes, it's going to need to be updated here. And so it could change if we update what the project description says or what the value on it is, or whenever a new project is created, the way we kind of, whoever is managing that treasury has the ability to grant final approval to a project listing by making sure that the correct project hashes are added to this updated inline datum. And so I hope you can see that there's a seedling of governance here. We still have work to do sharing this work. That's the work ahead this year. But this really gives us an outcome. This is the place we want to get to. We come together, we decide what projects need to be listed, we decide how many tokens to allocate to each project. And when there is sufficient agreement, the hash for a project gets added to the inline datum. Let's see if this one is here, A05F7. Here it is. And so if I try to commit to this project, it's going to be no problem. Okay, here's a successful transaction ID. It'll take a few moments for this to be confirmed on chain, right? But basically we have a successful transaction ID because the entire process managed by Mesh resulted in a success notification. Any questions so far? While we wait for that, I want to point out, right, the condition of this page is probably not production ready. It could be more beautiful. There are other ways to represent contribution tokens, and there's currently no logic for managing the case that we see right here, where maybe a contributor has multiple valid contribution tokens and they want to choose which one they're using. That's not built yet. For now, most people have a single contribution token anyway. We've got the project details. You can see maybe this would be rearranged. And then down here, this is the component inside of the React project that has all of the transaction logic in it. We'll look at it in just a moment. And it's got this little dev details button. All right, this is not really for production, but if you're learning how to use this thing, I do recommend tapping this button to take a look at how data is organized for all of these different purposes right here. And here's another way we could see that treasury data. This is the current, what's currently up on chain. Okay. So really, I hope that you see that this is meant to be a teaching tool as much as anything. I want to give people a chance to experiment with this, learn how to use it, have questions about how data is organized, for example.
So that's really nice, James. I'm wondering when, when it didn't work there at the beginning and you knew it wouldn't work, you didn't go to this, you didn't go to the dev details. Would you have learned it that way also, or?
Yeah, you could, right? Like if, and here's the thing, right? I'm showing you a mistake that I hope would happen, right? A failed transaction that's supposed to fail. It can be mysterious sometimes still why Plutus validation fails. I think one of the things we can hope for this year is actually being able to clearly see a Plutus error message reported in a front-end project. That's going to be a really, really nice thing to have. And we're getting there. But yeah, I could have looked down here at the treasury datum and I could have showed you that it's not in this list. The hash is not in this list.
Yeah.
If I refresh this page, I'll need to connect the wallet again, but if I do, you can see now I only have one contributor token left in my wallet. Remember that every time a commitment to a project is made, the contribution token is locked up along with the rewards. This is because we really want to inspire people to focus. Hey, commit safely to one thing at a time. Do it. Get those rewards, get your contribution token back, then go do the next thing. I don't know if that's just that. I'm just looking forward to having that kind of focus in my life. So maybe I'm being a little too opinionated here. But I really hope that this can be a thing that forces us all to say, hey, let's lean on each other. Let's be a group that can do one thing at a time together. And let's watch what results happen when we take that approach. Now there's a list of contribution tokens right here. There's a couple of test ones because I've been playing around with a couple things, and this is what pre-prod is for. And I can mint one of these for anybody, and I'll show you the minting process at the end of this call. But you can see that there's this mastery data for each contribution token, and then there's this number of contributions data. There's also down here a list of static contribution tokens with this policy ID because we've been doing this since before the token pairing logic was first created. So you'll see that some of these token names start with 222, some of them start with 100, and some of them don't start with a number at all. The ones without a number on the prefix, those ones are kind of the original version of the contribution tokens. They have the policy ID that is required to commit to a testnet project. Okay. These numbered prefix ones are the only thing we're using on the mainnet instance. And they're what allow us to look at this data right here. So Demeter runner, if I go to the current list of commitments, is the contribution token I see right here. It's locked up. And the one that the contributor holds in their wallet is the one that has the 222 prefix on it. This is not a perfect implementation of what is suggested in SIP 68 and 67, but it's a test case. And the precise naming conventions we use in the long term, we can play with those. But the idea is here. The one with the 222 goes in the contributor's wallet. The one with the 100 prefix lives at a contract address. This contract address has all of the 100 prefix tokens in it. Actually, and sorry, this, again, I have a couple of things to fix between the two implementations. This is the mainnet contract address. So you can see there's all these 100. Let me go to this policy ID on pre-prod. Find a 100 prefixed token. And I can see that the address, here's going to be the contract address. So here's the pre-prod version of the same thing. And you can see that all the tokens here have this 100 prefix. The critical thing here is that at this contract address, along with the 100 prefix token that matches one-to-one the names of each of the 222 tokens, right? Everywhere that I see a 100 prefix, there's a corresponding 222 prefix, okay? The one with the 100 on it is where this data is held. And what are the implications of this? This is the critical thing. Because of these token pairs, the data right here can be updated by looking at the contract address where that inline datum is held without the need for the token that the contributor is holding in their wallet. The contributor just holds that token as if it's any NFT or token, whatever. But the data associated with it can change over time. No minting or burning is required. So what I'd like to do next is show you this transaction where we're gonna, there's actually two distribute buttons right here. This one works with any token and it doesn't increment the contribution data. But this one right here is both distributing, and it will update that contribution datum. Okay. Now I think in this wallet right here, I don't have the issuer token I need, so I got to switch wallets. I'm going to refresh the page and reconnect with that wallet. And now you can see I have this Treasury issuer pre-prod token. Again, not much attention to design on this page right here. Okay, we're playing with kind of the concepts and the plumbing right now, making this thing beautiful. That's part of the work ahead. But let's distribute this thing. Since I have the issuer token, I'm going to be able to distribute this commitment. It's a more expensive transaction because more is going on. If we look at the details, we can see that there is this is actually the reference token with the 100 prefix on it, okay, where the data is going to be updated. And then unlocking from the escrow contract and the 222 prefix contribution token that are going to go back to the contributor. Okay, I mentioned there's two contracts we're interacting with. You only see one right here because there's only one contract receiving any tokens. But all of this is being unlocked from the escrow right here. Now, when I sign this thing, we're good. It's going to take a few moments to appear again. So once again, I can show you this page also has the purple View Dev Details button, where you can look through, once again, some of the data that we are constructing under the hood with Mesh. Any questions? See if this transaction went through. I'm not sure why I'm getting a slow response right there. If I refresh the page, will I still see it? There's a bottleneck somewhere. This is why we're building Dandelion, of course, because we got to be able to pull information from the chain to build stuff like this. Okay, but as you can see, we no longer see that locked up commitment UTXO. And if I go back to the contributor tokens page, remember how Demeter Runner had 3 contributions a moment ago? Well, now they have 4. And that's all automated. Okay. So it looks like a pretty basic system, right? This is what I would hope that some kind of contribution logging system does. And we can make it look relatively simple on the front end. But just keep in mind what's going on under the hood here. This data is on chain. This data lives in inline datum at a contract address. And there's no database other than the Cardano blockchain being used to make this happen right now. It's a headless app. So I'd like to look at these transactions. This code base is all on GitLab. And I shared that Obsidian link before. This link has everything into the chat again. If you're looking for the Git repos, the agenda of today's meeting, or next steps, it's all right here at this link. Okay. Now inside of this project, first of all, there's a couple of branches here. There's the main branch where development work can happen. There's a pre-prod branch. That's the one we were just playing with. And then there's this mainnet deployment that's live at gpte.gimballabs.io. We want to make sure that we are on the main branch, which is where, we can start additional development work from. We should really understand the pre-prod and mainnet branches as snapshots in time, because as we start to tinker around with the work that's happening, obviously that could change behavior, and we want to just pay attention to the implications of that. So as I show you around, I'll be on the main branch right here, but you can look at specific instance variables by switching to any other branch or creating a fork or a branch of your own. The two transactions we were just working on are in the components directory and the transactions subdirectory. You see we have the commit to project and the distribute from escrow transactions. I'm just going to open both of those up. And we'll look at the commitment one first. We do use a GraphQL query to grab the UTXOs that are currently at the Treasury address. A bunch of different hooks, because a bunch of different information is being passed back and forth as we build this transaction. Use effect hooks as well. And we can dive deep into any of these anytime. But what I want to show you today specifically is the transaction build step. We're almost there. Here it is. Handle project commitment. So when we press the button, okay, keep in mind the entire commit to project component we're looking at right here is everything in this box, right? It's this for production box right here. And the button we're talking about here is this commit button. So when that button is clicked, it triggers this handle project commitment event. And this is where the transaction is initialized with the connected wallet and where our interactions happen. So what's happening in this transaction? Well, we're trying to redeem value. This is a mesh function from the contract address. We're using a reference UTXO as our Plutus script. So looking at that Plutus v2 script that's at a reference address on chain and has our Plutus data in it. You might have noticed that the cost of this transaction was about 0.84 ADA right now. I think we can get it lower than that, but it's certainly a lot lower than it was. It was as high as about 1.5 ADA when we were using Plutus v1 scripts, including them every time on a transaction. So there's still some optimization to do here, but simply by making the switch from v1 to v2, we just about cut the transaction cost in half. There's some datum here, and this is what we want to look at together, and a redeemer. This is, again, the unlocking from the Treasury contract. Then value gets sent. Where? To two different places. Some value gets sent back to the Treasury, because every time somebody commits, they're not unlocking the whole Treasury, right? They're just unlocking some of the ADA and some of the Lovelace in a project. So the change gets sent back. And critically, we got to remember that the Treasury datum needs to be attached once again. And in this transaction ought not to change. Our Plutus contracts, Adrian, thanks to Adrian, check that that datum is unchanged when it goes back. And then there's another output sending other value to the escrow contract with the project datum. And in both cases, the datum is going to be inline. Okay. We also throw some metadata on right here. We see that the transaction is built, signed, and submitted. If it's submitted successfully, we get a transaction hash, and that's when the modal opens up. Otherwise, we get an error. So now, as you can see, this is all abstracted away. So you have to look at the rest of this file to find where the contract UTXOs array is constructed. The treasury reference UTXO and the treasury address, those are project variables that are kept in the Cardano folder, Plutus. And if I look at treasury contract, for example, you can see that all of the necessary variables are here. We keep this CBOR. This is not even being used anymore, but I was using it in testing. Here's a copy of the treasury datum. I would like to get to the point where we don't have to keep this anymore in a TypeScript file, but just it's being pulled down from chain and then reconstructed when we create any treasury interactions. Okay, here's the contract address for the treasury. Here's the reference address I'm using, policy IDs for different tokens. And it's, I don't think we're 100% there, but I think with a couple of little exceptions, everything you need to do to customize an implementation of this app is right here in this Plutus folder. Escrow contract. The CBOR is here for reference. The address is here, and a reference UTXO. This is the type defined by mesh to handle UTXOs. This is what we're using as our reference UTXO. So it's on-chain hash index 2 reference address. This is the amount of Lovelace in that reference UTXO. And then, oh, right, we are. So this is interesting. And I'm wondering if there's other ways to deal with this. I am actually using the CBOR here in the front end, but it's not being uploaded to the chain. I'm just using the CBOR so I don't have to pull it down and then add it to a UTXO object every time I want to use it. We're able to just construct this UTXO. And essentially what Mesh is saying is, hey, we know this UTXO is on chain, right? We know that at this TX hash and index at this address, there's this much Lovelace and there is a reference script. So we don't need to query the chain to find that out because we already know what's supposed to be there. But if this thing that we were saying is supposed to be there and that we were using when we tried to unlock a transaction with this UTXO, if this turned out to be wrong, then of course the Cardano protocol would notice that and it would not validate the transaction because it wouldn't be able to find that information on chain. Yeah, well, that's right. This saves us an API call just to embed the CBOR right here and have this UTXO ready to go.
Is that something that would get caught immediately, or is that something that would get caught and cause collateral to get burned? Have you tried incorrectly?
It wouldn't, yeah, it would get caught before collateral was burned.
Okay.
Yeah. Yep, good question. Okay. So obviously there's a lot that we could cover here, but I just wanted to show you that I guess we have to look at the contract to really see this bit right here, right? Without the treasury data, the transaction is going to fail. And so let's jump into just the treasury contract for a moment. Oh, language server, we were just talking about that. I'm not going to do that right now. Oh, this is the treasury. Well, so two things have to happen, right? We can't, in a commitment transaction, first of all, we can't change the datum.
And then I put on the counter because
Okay. Right, so that's good. Right. We wouldn't want somebody to be able to make a commitment and then spoil all the data in our treasury. But what's more important actually for this is the escrow validator, right? Oh, no, it has to be right. It has to be here. Yeah. This, sorry, I'm looking right at it. Not a valid project hash. That's the one I wanted to look at. So we have a helper function that says, check the project hash of B. What's B? It's the redeemer parameter that's being passed via action. Treasury action can have a B on it. But if I look at now the types, and I look at the treasury actions here, I can see that commit has a parameter called project details. Project details has a project hash that we pass in it. And that project hash, if I go find this function, check project hash B, that has to be an element of the project hash list in the datum. If it's not, the transaction won't validate. How do you feel about that? It's elegant, right? I mean, that doesn't take too much code to give us that level of security. Okay, and so right here, in order to validate, we both need to see that the treasury datum is unchanged, going back to the treasury address, and the project datum that's outbound to the escrow contract has a valid hash in it. All right, so at this point, we could spend a while looking at other stuff here, but is it okay if I move on from the commitment transaction to the distribute transaction? Dan, I'm so grateful to be able to see somebody nodding. Thank you. Okay. Keep in mind the shape of this transaction right here, right? We can look at all the other logic that creates, like I said, all this other stuff that we are including here, but this is the meat of it, right? When we press the button, we want to build a transaction that does some certain things, okay? And so you can look through on your own to see how values are created, like where does this UTXO back to treasury come from? Just search for it in this file, right? Where does the UTXO back to escrow come from? Same thing. You can go look at where that's constructed. But keep in mind this general shape. We have one redeemer, we have two send values, and we got some metadata. So what does the distribute transaction look like? Let's find that transaction handler here. Here we go, handle distribute transaction. So what's this one doing? This one is redeeming value from an escrow address. And it's simply sending some value back to the contributor. This line right here, send assets, is looking in the currently connected address, which if we're distributing, we would presumably be the issuer, the owner of the treasury. So it's looking to see that an issuer asset just gets sent back to this address. And this is a really elegant little trick we can do, if you've ever played with Cardano CLI, you know that we need to look in an issuer's wallet if there's some administration token we're looking for. We have to find that transaction hash, include it as an input, and then also include it as an output. Mesh abstracts that work away from us, and it feels really good. It saves a lot of time to simply say, hey, that contract requires me to have this asset in a transaction. Well, guess what? All I'm going to do is send it to myself. And by doing that, cool. Now it's part of the input and the output to that transaction and can be validated against. Really helpful. So Dagwell, you were singing the Cleese praises yesterday. But I'm finding more and more that, man, I would rather be testing in this environment.
Oh,
Okay.
I'm not going to take that away from you at all, but you understand the underlying technology that makes that so clever.
That's right. Hey, preach, baby. That's right. Once you understand what's going on under the hood, I hope this feels like a nice little time saving. Okay. All right. But now this actually isn't the transaction I wanted to show you. This is just the simple distribution transaction. Down below, here's the one that distributes and updates the reference datum. So there's a bit more going on. Notice we are redeeming from the escrow address like before. We're also going to redeem from this reference address. This is that address that was holding those 100 prefix tokens. What are we going to do there? Well, we're gonna spend, right? We're going to try to consume a certain UTXO from there, the one that has the contributors token. And then we're going to send back to that address some updated datum with a UTXO that still holds that token. Sending to the contributor is easy. That's just a simple send value, right? We have the contributor's address. We know what we've got to distribute to them. We just send it. But the contract that we are both spending from and sending to is the one where that inline datum is held. Same trick with the issuer asset, throwing some metadata on there. Any questions at this point? So let's look for this bit right here. Where is updated contributor reference datum coming from? Okay. It's a use state hook, so it's set right here when we get some updated datum. Where's updated datum coming from? It's a mesh data type. And so you might recognize from looking at redeemers as JSON for CLI interactions that this looks a little bit similar. But the way that mesh and its TypeScript library construct data, it won't take you too long if you already understand how to write like a JSON file to include in a Cardano CLI transaction. It won't take you too long to wrap your mind around this. But if you ever get stuck right here, just be sure to reach out for help, okay? We've got, and actually here, let me open this up. This is the datum at the reference contract. Let's just look at what this looks like in Plutus. So I have a type right here. Okay. So here's the contributor datum as it's defined in Haskell, where we have a map from byte strings to integers of our mastery levels. So we're able to say like module 301, and then we can put an integer there for the level. We can have an integer that represents the number of contributions, and then we can have the contributor's alias right here. This, as we're going to see over the next few months, this is where inter-community governance, we might even call it network state diplomacy, starts to take root. Because by defining this data type and then using it in the validator, that allows us to update. You see, this is a very simple validator. There's not many guards in it, right? We just want to make sure that that data is coming and going according to somebody's access rights, okay? And that datum is being included. But if I change that datum, then this will compile to a different contract address. In other words, there's a direct line from the structure of the reputation datum as we define it to the contract address that's holding that datum. I think this is pretty cool, because as communities start to pursue interoperability, right? Another community wants to use a Gimbal Labs contribution token to assess whether or not somebody should be able to make a contribution.
What do you mean there's a line?
So there's a direct technical line from how I define this contributor datum type right here,
Yeah.
to the address of the contract that's going to hold those reference tokens.
How do you see it?
Well, because this is how Plutus works. If I change this data,
Yeah.
and I recompile this contract now with that changed data, the result of that compilation is going to be a different address.
Okay, wait. So this reference validator, reference params, contributor datum, reference redeemer, script context, that's the line?
So when I said line, I was talking about like in your workflow, any group that wants to have reputation data and wants to be able to update it, like I showed you at the start of this call.
So
Right.
James, is this a contract parameter?
This is a datum.
So how this changed the hash of the contract? I didn't get it. If it is not contract address.
If you add a parameter to the record type, if you add, don't know, instead of contribution count, you add it as a built-in byte string. Yeah, exactly.
Okay, I get that.
Right. If I add a field right here, now this is a different data type than it used to be.
Yeah.
Right. That data type is used here and results in a different validator.
I thought the inputs, I mean the variable, the value of this variable will change the contract. But okay, the type sure, definitely.
Yeah, the type. That's what I'm saying, right? So within this type, there is actually a degree of flexibility, right? Right here, we can create any map of built-in byte string to integer without changing this contract, right? We could add as many mastery, like as many mastery modules as we want. This is a string instead of an integer because maybe we would want to have them have names, right? You could argue that maybe this could have been an integer and we could have just written 301, 302, 303. I went with a string in the first implementation just to give us that flexibility, right? What do we want to measure here? And as a matter of fact, I'm already cheating a little bit when I added an instructor tag to this mastery levels data right here. So after module 301, 302, 303, anybody who's been an instructor on the course also has a map from instructor to a 1. Okay, so, and that's how they would have, for example, this instructor tag right here. Okay. Whoops. But I think this is really interesting. I'm eager to explore across communities what people need in their contribution datum. And if groups decide to work together, one way to, I believe the word contract is really compelling right here, right? One way to create a contract that represents a relationship between communities is to agree to sharing some structure of reputation datum, and therefore be able to rely on that and have that kind of interoperability, right? All of this, one thing we're not doing yet is using this datum to create new rights and privileges, right? The current iteration of this commitment contract, or the treasury and escrow contracts where we can commit and then distribute, all it relies on is a policy ID being present, right? The policy ID for this contributor token. But you can imagine a scenario where somebody could only commit if they had a certain number of contributions so far, or a certain level of mastery on a given module. Or maybe you want to mint another contribution token that comes with a higher level of access or a different level of access. You could look at whatever you want to in this reputation data, or whatever this becomes over time. I don't expect it'll look like this a year from now. But we could look at this datum and we could use it directly in some validation logic. So I'm excited about that. And you can see on the front end, this is where this gets built. We go through the existing, here we do have to query the chain to pull down that data. We have a helper function right here, get inline datum for contributor reference. That makes a quick GraphQL query. It pulls down the datum value and returns it. Then we look through that datum. We look in the field. We only have to worry about the first index of the fields in this case, because we know what we expect to find there because it's defined right here. And we map over that and we just say, okay, look, the mastery data is not going to change. So let's just set all of that again, but let's just increase the contribution count by 1. And so the mastery map right here is just a copy of what was already on chain. The contribution count is incremented by 1, and the alias doesn't change. How we doing? We're packing a lot in here, but I'm excited to be kicking off the year just by kind of throwing these transactions at everybody. And we're going to continue to kind of understand this together and talk about what's next. Okay. Anybody have any questions? Cool. Okay, so real quick, I just want to revisit the agenda. My goal was to look a little bit about how the treasury datum is used in a commitment transaction. I showed you success and failure there. to look a little bit about how that datum is incremented on the distribution transaction. That's what we just focused on. And it looks like, yeah, we have just enough time to take a quick look at how these contributor tokens are minted in the first place. We can stick around. Okay, good. Dan will follow up. And Steve, let me do a quick treatment of this, and then let's take a survey of some of those follow-up questions so we can think about next steps. I'm not going to save any changes here. Close the rest. And let's look at now. Okay, this one, first and foremost, there's a secrets file right here. So a little disclaimer. You are looking right here at a Cardano private key. Don't do this. Don't do what I'm doing right now. Okay. I'm giving you a pre-prod example for demonstration only. And please never, ever put mainnet keys in a front-end project where you might be susceptible to pushing that live or sharing your screen with somebody. Okay. This is the very same thing as a mainnet key. And if somebody has this, they have access to all of your funds. Okay, so anybody watching this video, you can just grab this key right here and start minting pre-prod commitment tokens, okay, on your own. Just grab it. But I just want you to see that this is what's now possible because of some of the new features of Mesh, specifically App Wallet allows us to integrate a wallet with a project in all sorts of different ways. Okay, and one way is just to grab the private key that you generate on CLI and use it in embedded wallets across a project. Now, this does make it really convenient to mint tokens quickly, okay? But it's also a security concern. If you were going to use this in production, you have to keep this a secret, and that's something obviously we're probably going to need some DevOps modules about the best ways to do that. But also what's nice about this is that if you've done this before, this is Web 2 security as well, essentially. So if you know about Web 2 security, you shouldn't have too much trouble doing this part right. So I just wanted that disclaimer first. Now, this is just a simple project. I think I still have everything just on one page right here. It's all integrated. Okay, so let's take a quick look at what it is first. I want to be in this directory. Okay. And okay. Not much to it here. Connect a wallet part. Connect a contributor's address and alias. Okay. And then you mint a pair. So let's look at what this looks like on the Mesh side. This needs to be cleaned up. This really isn't even ready for public sharing yet. Okay. Because I have to clean it up a little bit, but basically we just have that form that grabs a contributor's address and alias. We create a map of mastery data. I'm struggling a little bit right now, taking inputs from a formic form and getting them to be recognized as data in Mesh. So if anybody wants a puzzle to solve, This one is kind of interesting. What I would like to have is a form where I can not just drop somebody's address and alias in, but I can also quickly just type in their mastery levels, or in the long run, grab these from the Canvas API, right? It'd be great to just look at the results in Canvas and and pull those results directly. So that's a place to get to. But for some reason, when I was using the form values and trying to do it this way, it wasn't showing up. So I could show you the result of this.
Is this what you were messing with Monday?
This is one of the things I've been screwing around with, yeah. You can see my test right here. I tried to mint with a form where I was able to write in those mastery levels, and it didn't take that datum right here. That was Plutus right here. Now the good news is, even when a mistake like that happens, you can still go edit this data, and that's a good thing, right? Because maybe somebody who doesn't have, maybe they've met some minimum requirement in some way, like test contribute 03 right here, right? They say, okay, well, I got to level 4 on one module, mint me a token, please. Great, you met the minimum requirement, but maybe they go back later and they finish modules 301 and 302. Of course, we would want to upgrade that. So the reference contract allows for that. And it also allows, if data is erroneous or even missing, we can come back and we can change that later. So we set that data here. Got a little dev challenge here. Maybe this becomes a project on the GPTE. We build that initial datum, and this should look familiar, right? This looks similar to how we were constructing the same datum in the distribution transaction. The recipient, oh, sorry, right. There's going to be 2 tokens minted. The recipient, one recipient is the contract address that actually gets the datum. And the other is the wallet address, the contributor address that's input in the form. So let's look at this transaction. We say, okay, just like before, let's initialize a transaction. Let's mint a couple of assets, a reference asset and a contributor asset. What's reference asset? It's up here. It's got that 100 prefix on it. What's contributor asset? Here it is. It's got the 222 prefix on it. There's some metadata. There is some, and this is handled. That could be one. Yeah, I got to check that. That's the first thing to check. Exactly. Look at the way Mesh handles 721 data. They actually make it really easy to mint an NFT. I can just build out some 721 compliant metadata. For example, like this. That should look familiar if you've minted NFTs. And then I could say, okay, this is a 721 and not a 20, right? Which for a fungible token. But then I also want some additional metadata that's custom to this implementation. And so I can set additional metadata here. And this is just an instance variable. This other key could be whatever you want it to be, and what's in that contributor data. This is some of the stuff, if you were here for the conversations about the contributor tokens last fall, we looked at some of this. And so this is going on that other key. What is the other key? It's an instance parameter right here. but again, could be anything. We need the extra signer because we're using an extra minting key, so our minting policy. Right? You don't have to keep this part a secret necessarily. This would show up on Pool PM if you registered a token. Right? We need signatures for both of these pub key hashes. And that's what's in those secrets that I showed you at the beginning. Okay. But it's pretty nice. Mesh can handle all of this for us. It allows us to mint those pairs of tokens and populate some initial metadata, or metadatum, I should say. Any questions about this part? Anybody want a testnet pair? A testnet contributor token right now, so you can play around with the testnet implementation. We can live mint you a token. I'll just mint one for myself just to demo. All right. We'll call this one live demo. And again, got to make that form. But let's say this one got 222 as the initial mastery data. All right. If I mint it, I got to connect a wallet. Let's try again. If I go to mint this thing, you can see there's the 721 metadata right here. You can see there's the additional metadata at our arbitrary key right here. You can see that this contract address is receiving the asset with the 100 prefix on it. And because I'm minting this for myself, you don't actually see that, that I'm listed as a recipient here. But if I go back, you'll see that I'm going to spend this much and I'm going to get this asset. This is the one with the 222 prefix on it. Yeah, Juan, coming at you. Excellent. So I'll mint this one and then I'll mint yours. So I'm going to sign this. I don't need any access token for this one because I've got some private keys embedded directly in this front end project. Okay. But you could imagine how this could also be a Plutus minter, where it's not about storing private keys. It's about just, do you have the token that gives you access to mint something? So that's, we could do that soon. All right, so let's do this again. But let me just turn off this. All right, I'm gonna live mint one of these for Juan. What alias would you like on this thing? Okay, let's mint this one. This time, you see it's not coming back to me. All right. So this time, the 100 prefix goes once again to the contract address. The 222 prefix goes to Juan's address. we can see those token names in the 721 metadata. And look, it's, you know, I'm sending from this wallet, it says a total of 2.81 ADA, but most of that is just the min UTXOs that are required. That's another thing that Mesh makes it easy to do. I don't have to do anything to calculate these. Those are calculated in the background. And the fee for this minting transaction isn't bad, less than 1/4 of an ADA. All right, so that's on its way. Okay, that was a lot to pack into 90 minutes. And it's okay if it takes us the next 2 months to go through all the questions that all of us have. I still have questions for myself, so I can only imagine that people here are going to have questions now and later. So please know that, you know, I was hoping that this session would be a place for us to start. And yeah, we raced through this. But this video is recorded. You can review it on YouTube. You can go back to some of these details. And one of the things we have to do together over the next few months is figure out how the PPBL course needs to be updated. We originally released it back in July. Demeter didn't exist then. Mesh was in its infancy. Nice, it's already there. Excellent one. Okay. There's lots of great new documentation, and this project has come a long way. Okay, so there's a lot that we can think about how to revise that course. If that's exciting to you, to support that refinement and updating of the course, let's talk about that. And that's just one of several things we might choose to list on the live deployment of GPTE. So tomorrow, we're going to pick up by starting right here at this list of projects on the live instance, right? And we're going to talk about what needs to be listed on this page. This is not a comprehensive list yet, and there's a lot more work to do than is listed here. So let's start figuring that out together. Let's write descriptions and figure out reward amounts given what's in the pool right now, to do as much as we can and to start building this reputation organically. So thanks, everybody. I'll stop recording, but let's if anybody wants to stick around, Steve, I would love to like elaborate on some questions with you while they're fresh on your mind. Is that cool?
Let me see if I can articulate them.
All right, we'll try. I'm going to stop the live stream. For anybody who's watching this later, hope to see you